So welcome to this is the Further Math Support Programme online revision session for OCR Statistics 2. And in this session we're going to be looking at the concept of continuous random variables. So key things that you need to be able to do, you need to understand what a CRV is, a continuous random variable, in terms of its properties of probabilities and also the ideas associated with it. You need to be able to use the properties of it, and in particular properties of its what we call the probability density function. And from this we also need to be able to work out the expected value and the expectation and the variance from a PDF. So, June 2010, question 8. We're given a continuous random variable x and we're given the probability density function. And we're told that k and a are constants and that a is greater than 1. And we've got to show that k is equal to a minus 1. So before we start this, there are a few key properties that I'd just like to emphasize for you. The first one is that this is continuous. So instead of the sum of the probabilities equaling 0, we actually have the integral of the probabilities over the support. So we're going from 1 up to infinity of k x to the minus a with respect to x actually has to equal 1. That's one of the key properties about a continuous random variable, the fact that the areas must work. Okay, so this is in fact what we're going to use to do this question. So first of all, I can pull out the constant k. It gives me x minus a dx, and I know that that equals 1. So if I actually carry out the integration, I increase the power by 1, divide by the new power, which I'm going to write as 1 minus a for convenience, and we're going to evaluate that between 1 and infinity. Now you may have been taught on previous modules that we really shouldn't put infinity into an integral like this, and we have to change the variable and then see what happens. We don't really worry about that too much at this level, because it's the same as putting infinity in, so we can. You just got to do it very carefully. So if we put infinity into this, we end up with x to the power of minus infinity, which in fact gives me 0. So I'm going to end up with 0 minus, now if I put 1 into this equation, I get 1 to the power of minus a plus 1 divided by 1 minus a. And again, all of that should equal 1. So I'm now left with the statement that k divided by 1 minus a negative equals 1. So minus k is equal to minus 1 minus a, so k is equal to a minus 1. So we're based on the fact that we understand that the integral of, effectively the integral from a to b of your function must equal 1. So where are marks allocated here? Well, you're going to get 1 mark for integrating with limits of 1 to infinity. Okay, so actually carrying out the integration is going to give you 1 mark. Okay, you get a B mark for actually then realizing that that's going to evaluate to give you 0. Okay, and then your final accuracy mark for getting the correct one. Now, if you are wanting to do this in a more correct way, you have to realize that the integral changes here. Let me do it in a different color so you can see. So it all depends on how you've been taught this, but a more correct way of doing it would be to realize that it's the limit as t tends to infinity of the integral of 1 to t x to the minus a dx. And what's going to happen here is this becomes limit as t tends to infinity of k x to the minus a plus 1 over 1 minus a between 1 and t, and then eventually you end up getting back to this point here. So that's if you want to do it more fully, but that's all we're expected to do here. Okay, so for part 2, we're now asked to find the variance. So we're going to do the same sort of idea. So I'm not going to take limits to find things. I'm just going to evaluate it at 0. So as you know from previous modules, the variance of x is equal to the expectation of the squares minus the square of the expectations. So finding this is quite critical. So the expectation of x is going to be the integral, first of all, from the lowest value to the highest value of x times by the function. So that's going to be k x to the minus a times by x means I add 1 to the power I also need to work out the expectation of x squared. So again, that's 1 to infinity of kx to the minus a plus 2 dx. So we need to evaluate each of these separately. We are also told now that a is equal to 4. Okay, so therefore I know that k is also equal to 3. So that's going to make my life considerably easier in this question. So the expectation of x is going to be the integral from 1 to infinity of 3x to the power of minus 3. Okay, and if we integrate that, that's going to give me 3x to the minus 2 divided by minus 2, evaluated between 1 and infinity. And again, we're going to assume you can do the substitution correctly, but that's going to give me 3 over 2. The expectation of the squares is going to be 1 integral 3x to the minus 2 dx, which, if we carry out that integration, is going to give me 3x to the minus 1 over minus 1, evaluated between 1 and infinity. And if we calculate that correctly, that's going to give me 3. So the variance of x is now going to equal the expectation of the squares minus the square of the expectations. And if I calculate that through, that's going to give me 3/4. Okay, so quite a lot of work for this question. So let me just change my colour and I'll show you where all your marks are given for this. So you're going to get 1 mark for doing the integration for e to the x, ex. You're going to get 1 mark for doing the integration of x squared e. So you're working out e of x squared in that context. You're then going to get 1 mark for getting either of these correct. Okay, and that will be an accuracy mark. You then get another method mark for getting this idea correct here. Again, the numbers don't need to be correct to trigger that method mark. And then your final mark comes from the accuracy here. Okay, so quite a tricky question, quite an involved question on this, but you know, it is worth a lot of marks, but it's just important really. And then part 3, we're asked to find the probability of x being less than 2. We're given this and we need to find the value of a in this particular context. Okay, so I know that the integral between 1 and 2, 1 because it's the bottom of my support, 2 because it's what I'm trying to find here, and this is going to equal a minus 1, because I don't know what k is, all I know is k is a minus 1, x to the minus a dx. And I know that that's going to evaluate to 0.9. So that's going to enable me to do this. So we carry out the integration and basically see what happens. So if I integrate this, that's going to give me a minus 1 x to the minus a plus 1 divided by minus a plus 1, evaluated between 1 and 2. Now there's some cancelling that can be done here because the numerator and denominator are the same up to a negative factor. So that's going to give me minus x to the 1 minus a, might as well tidy that up as well, between 1 and 2. And again, I know that that's going to give me 0.9. So putting numbers into this, if I put 1 in for my value of x, that's going to give me 1. And if I put 2 in for my value of x, that's going to give me, it's going to give me, so I put my top limit in, let's do that again, put my top limit in, I'll do it the right way around, that's going to give me minus 2 to the power of a minus a plus 1, you'll see why I've written it like that again in a minute, minus 1, and again I know that's equal to 0.9. So you may want to tidy this up and get 1 minus 1 over 2a to the minus 1, and that has to equal 0.9. But either way, you can see by doing all these calculations, if you then tidy this up, 2 to the a minus 1 is going to equal 10. Okay, and then of course to solve this, we're going to take logs. Okay, so taking logs of this equation, we're going to have a minus 1 ln 2 is equal to ln 10. So a is equal to, excuse me, is going to equal ln 10 over ln 2 plus 1. and that's going to leave you with a value of 4.32. So again, let me show you where these marks are allocated. Okay, you're going to get a method mark for setting up the integration technique. You then get a dependent method mark for starting to rearrange this equation. Okay, you then get another method mark which is not dependent on using logarithms, and then an accuracy mark towards the end. Okay, so moving on, we're told in this question that we have a continuous random variable t, and it is equally likely to take any value between 5 and 11 inclusively, and we're asked to sketch this. Okay, so if we think about having an axis, it can take any value between 5 and 11 that's continuous. So it's going to look something like that. But of course, we've got to consider what happens below in each case as well. So we generally do this. So this is called a rectangular distribution because, as you can see, it's drawn a rectangle. Now I'll be putting 1/6 here as well because I know the area of this has to be 1 because it's a probability. So that's some additional information that I'm looking for. Okay, so you get 2 marks here, one for drawing the horizontal line, and you get your accuracy mark for making sure that these bits are on as well. So you can see it's quite important that we consider the entire thing. We've then got to write down the value of ET and find by integration. There are other techniques, you see, so we've been asked to do this by integration. So E of t. Now if it's a rectangular distribution, it's symmetric, so E of t will be slap bang in the middle. So we can see from that E of t must be 8. We also have this, which is your function. So you can see by doing that you're also creating quite a lot of information beforehand. So I know E of t is 8. Now to work out the variance, again the variance of t is equal to E t squared minus E of t all squared. So again I'm going to need E of t squared. So by definition E of t squared is going to be the integral from the smallest to the largest value of x squared times by the function that we're dealing with. Okay, so just integrating this, this is going to give me x cubed over 18 between 5 and 11. Okay, and if we work that out, that's going to give me a value of 67. So now to find the variance, we've got the variance of t is going to therefore equal 67 minus the mean squared, and again write it as something squared. It really is going to help, and if we do that we're going to get 3 as your answer. So it works out quite numerically nice at the end. So again, let me show you where marks are allocated for this question. So we get 1 mark, as it says, for getting this correctly. In fact, it's a B mark, not an M mark. We then get 1 mark for trying to do an integration with x squared. That's quite important. You get 1 mark for realizing your function is 1/6. You then get another mark for doing this correctly, and then your final mark for getting the correct answer. You can see how important working out using the variance formula actually is in this case. So that's quite nice. Next question, we've got June 2011, question 4, and again a different continuous random variable, and we're asked to sketch this. So we're asked to sketch it between 0 and 4, and we need to notice that actually we get a double turning point at x equals 2. So that's really the key features of these. So it's a symmetric quadratic on 2. So we're going to have something that looks vaguely like this. Okay, and again, we've got to try and keep the symmetry, and that's fine. So you're going to get 2 marks for this. You're going to get 1 mark for having a parabola, and you're going to get your second mark for it being where it's supposed to be, which is here on the axis. Okay, so that's quite nice. Notice we don't need to worry about values on the y-axis. So we're asked to calculate the variance. So as a reminder, to do that we need E of x and we need E of x squared. So these are just laborious questions, they're quite long. So let's work out expectation first. Now we don't really need to worry about that because it's 2, because we can use the symmetry of the question to be able to do that as well. Okay, so we're really looking at E of x squared. So we're going to integrate from 0 to 4 3/16, that can come out because it's just a number. X minus 2 squared, so that's going to be x squared minus 4x plus 4 multiplied by x squared. Don't forget this is working out e of x squared for me, dx. So before you do anything else, you kind of need to expand that. There's no sort of clever pure maths required for these. You just got to kind of multiply them out and do it, really. So that's 4x squared, and then we are hitting the integration, which is 3/16 of x to the 5 on 5 minus 4x to the 4 on 4 plus 4x cubed on 3. And I'm evaluating that between 0 and 4. Okay, and I'll just do that quickly for you, and that will give you 32 on 5 when we do all of that. Okay, so now using the variance formula, we've got var x is equal to 32 on 5 minus 2 squared. Okay, and if we work all of that out, that's going to give me 12 over 5. Okay, which is 2.4. So it's just a long-winded question, these. So again, your marks, well, you get 1 mark again for trying to do this integration. You get 1 mark for multiplying it out, so you're using the correct appropriate technique for doing this. You get a B mark for having the correct answer here. You get another B mark because we're using the variance formulae correctly, and then an accuracy mark at the end. So you can see sometimes you get method marks, sometimes you get independent marks. It kind of depends on how the question works. Okay, so you just got to be aware of that. So again, not too bad, just quite long-winded. So a student writes, x is more likely to occur when x takes values further away from 2. Okay, and we've got to explain whether we agree or not. Okay, now it's to do with the notation, really. So capital X is a random variable, and little x actually is a value that the random variable takes. So and that's pretty much it. This statement is not true because x represents a value. So x is a value taken by the random variable. Okay, so it's a weird question, that one, quite frankly, but it's just trying to check your understanding about what's going on. Okay, so that's really what we're dealing with. So yeah, just be aware of that. Bit of a strange question there. So as you can see, one of the most important things about this is your ability to integrate polynomials and also understand your definitions of expectations and variances and probabilities.